All right. So a few people, great. So nice to meet you guys. Thanks for being supporters of the community. So if you know, PyTorch Lightning lets you build models. We basically extended PyTorch Lightning, which is now called Lightning, to allow you to also do research workflows and production pipelines. So I'm going to walk you through that. And it's really meant to be like the Lightning way, right? Which if you haven't used Lightning, you don't know what I'm talking about, but hopefully I will show you what that it looks like today. Um, so yes, so this is Lightning. So basically, kind of the general theme for us is like ML without the ops. The ops are basically deferred to the insights of the platform, and you guys can put your heads down so that if you have real questions, I know to call on you. So yeah, so it pushes all the up stuff down so that all you do is focus on like the science or the business problem that you're trying to do, right? So if you're sitting at a company or a research lab and you want to like, I don't know, do fraud detection or something, you basically end up having to like learn everything about the cloud and Kubernetes and so on. There are a lot of companies that provide great services to help you not do a lot of that, but I think something that's helped Lightning succeed and why we're kind of popular in the ML world is because we really take that to an extreme to literally just a few lines that you care about and everything else is gone. So what is Lightning AI? Lightning AI is the company and also the platform, right? So it is, you can go there right now. So it's lightning.ai. And it's basically a platform you can find, publish, and build research workflows and production pipelines. So instead of building everything from scratch, which you normally have to do, if you're like, hey, I want to do fraud detection or whatever, you have to go learn a bunch of different tools and then assemble them together. And like maybe 8 months later, you're good to go. Well, we've introduced this notion of a Lightning app, which is a full end-to-end workflow that already has all of it built in, using the best-in-class tools and companies and open source. And then you can then kind of clone that thing, run it on your infrastructure in a few seconds, and then you modify the code, right? So I'll walk you through what that looks like. So this is kind of the agenda so everyone knows. So question is always like, where are you in the stack? So I'll talk about that. The origin of like why this was even created in the first place. And then we'll talk about a few things that Lightning lets you do, which is obviously build, train models as well. And then research workflows, production pipelines, which are kind of the newer things that we've introduced this year. And then show you how to find, publish, and clone templates as well. And you can also publish your own ML products, right? So I'll show you what that looks like. So first, if you haven't looked at it, I just kind of compare it to some popular GitHub repos. So this is kind of like the explosive growth of Lightning in just a few years. We've already overtaken a lot of the super popular open source projects. And these aren't related, it's just kind of show you scale. But it's very, very quickly becoming the standard for building ML. If you look at, sorry, the slides are weird, but if you look at downloads as well, we're talking about almost 4 million downloads a month of this, right? So if you compare to like other popular open source projects, like there's not a lot that hit this category. And really what we wanted to solve were these, 8 things, I guess 10 maybe. So modularity. I think ML suffers from this problem where all the code is intermingled and it's really, really hard to swap things in out. Like, what if you don't want to use TensorBoard? What if you want to do some other experiment manager? Well, good luck. It's going to take you weeks, maybe months to like swap that stuff out, right? What if you don't want to use TensorFlow? What if you want to use PyTorch? Or what if you don't want to use PyTorch? What if you use TensorFlow? Or what if you want to train on TensorFlow and deploy in PyTorch, right? Like that stuff is like dreams today for people to do, which is stuff that we've made like a reality now with Lightning apps. Reproducibility. So Lightning is built in such a way that you can really, really take something and run it on any cloud and infrastructure fully end to end, and the code and the machines and the whole environment, everything will be replicated. We've also introduced this notion of declarative reactive Python. So the kind of paradigm today in ML, especially MLOps, is this kind of like DAG approach, right? Where you have sequential processing, and that's fine, but it really creates a ton of problems, right? It means you have to have these YAMLs that like have huge configs. It means that like how do you for loop a YAML? How do you do while loops? If statements, recursion. It gets really complicated. And a lot of the tools that exist today, like add all these weird like ad hoc capabilities to do that, where you should really just be writing pure Python. So we basically wrote a Python first framework that lets you orchestrate all of these workflows. But it's just Python. So you can for loop, you can do recursion, you can do whatever you want. It's fault tolerant, fully distributed, and so on. And it's fully flexible. If you're a Lightning user, you know that we take flexibility super seriously, which means that we want to abstract away all of the engineering so that you just have to focus on the thing that you're building, the fraud detection, the cancer detection, the deployment for an API or whatever you're doing, right? Now, if you are interested in the engineering, we give you ways of getting in there and just modifying it yourself, so you can make it fully modular. Readable as well. So I'll show you the code in Lightning is very easy to see and read. Like if you read through most machine learning code today, you're like, I don't know where the thing is happening. Like, where is the logic? Like 90% of the code is like distributed this, spin this up, cluster this, or whatever. And then there's like 5 core lines of like actually what the business problem is, right? In Lightning, it's you literally basically only see those 5 lines. Everything else is gone. Maintainability. So that function and that like structure actually like makes maintainability super easy, right? Because in the other projects where everything's messy and you just have code scattered all over and there's no structure, well, teams across companies can't really communicate with each other because they don't have a shared language, right? And then also, like you're gonna have to be maintaining distributed code and all these other things that like maybe that person leaves and then you're stuck with it, right? And you don't know what to do. So we handle on the open source side all of that complexity, so that all you have to maintain is a core business logic, which if someone leaves or teams change, it's totally fine. And then collaboration, right? So again, the ability for people to work together in the same project. In Lightning, with Lightning apps, you can have front-end developers with researchers, with ML engineers, with data scientists all working on a single app on their own individual components that are being kind of like glued together through the framework, and they'll never overlap or touch each other, right? But they can contribute to the broader application. And then local debuggability. So if you use Lightning, you know that I can debug, I can run a model on my laptop on CPUs, the same model that I can run on like 1,000 GPUs on distributed cloud, right? So, so we brought that debuggability and local testing to full distributed ML systems, right? So for the workflows, so you have a workflow that might be multi-cloud, multi-cluster. Well, usually you're like kind of running on the cloud. You like wait for the machines to spin up, you debug, and then you're back to your local, you make a change, and it's like half an hour to do that. Well, you can just run all of that locally, and then you mock some things that we enable you to do, and then that way you're going to have pretty good confidence that it's going to work really well. And this is really tested for scale. So remember, there's like over 10,000 companies across the world that rely on Lightning for really large production workloads. So this is like, where are we in the stack, right? So this is kind of like the ML lifecycle. Well, we're not really any one of these things. We're actually the white part, which is the thing that puts them all together. So I think a lot of the tools basically build a lot of these things into the tools, right? Like they'll have their own training things or their own deployment things, or they'll like overfit on like one particular experiment manager or whatever. With us, we just give you the platform. You build whatever you want into your apps. You want to use an experiment manager with this other thing, sounds good. You want to use data labeling with this SageMaker thing, with this other like private company thing that they publish, sounds good. You can do that too, right? So you're not wedded to any one particular tool. So if you decide to get off of PyTorch or TensorBoard, you can do that, and it's not a problem. You're not like stuck to the platform for that. So what does this look like in practice? So this is a workflow, right? So this is the Lightning app, what we're calling this, right? And so I'll walk you through step by step what it looks like. But as you can see in that run method there, it's all reactive Python. Like this is doing continuous training. It has an ETL pipeline. It has a DAG. It has continuous deployment. There's some scheduling involved as well. And it's all like 10 lines of code, right? Which is wild. And it's all just Python as well, which is cool. So I'll walk you through this example in more detail. So how do we do that? Well, first, let's look at the first part, right? So this is like a pipeline, right? So I'm gonna create a directory, and this is a distributed file system that's just implicitly built in, right? So as long as I just create a drive, it's kind of like this folder that lives across clouds, across clusters, but you don't have to think about it. You can move files, you can copy things in there, and it's totally fine. Then you have this data annotation stuff, data fetcher and transforms. This is what would be like an ETL pipeline, right? And then you have this feature store as well. And then you have the thing that's going to train and deploy. Again, this is an arbitrary example that I came up with, but like you can see how you can mix anything up. Like you want to build an app that does data labeling, you can do that. You want to build an app that does AutoML, you can do that. You want to do an app that does spin ups notebooks and then sweeps those notebooks as like actual Python scripts, you can also do that, right? You're not locked into anything. So it's like build your own adventure. So these components are also third-party components. Like you can find them on our gallery that are published by the community. So I showed you the chart with the massive amount of people that we have in the community. Well, all those people contribute these components that are really cool and scalable, and you can just use them. So you don't have to like go do a Tecton integration again or Databricks integration. You just find the ones that exist and then you plug and play. In a few minutes, you're up and running. And if you don't find them or you want to build your own, of course, it's pretty straightforward to do that as well. And it's just plain Python. So there's an event loop that's happening here in this run method, which is kind of what changes this paradigm, right? So the run method's kind of like iterating over and over again. So it starts, and the first thing that happens is you have this async call to this data annotation. So this thing starts, right? So I'm going to say, okay, cool, data annotation run. I'm actually missing an argument there called parallel equals true. So when I do that, it puts it into the background. And so you can start that annotating. So then the loop goes, and then the if statement's false because you don't have 1,000 annotations. Everything else is false. So it just continues going and going. Cool. If it takes like 5 months to annotate the data, sounds good. This thing's still running. It's fault tolerant. It's all good. At some point, you have 1,000 annotations. When that becomes true, then you're actually going to run this like data pipeline thing. So this is a DAG here, right? So this is how you can, you notice that we're composing DAGs in other workflows, right? Which is a very complex thing to do. But here is very trivial. So you say, hey, here's the folder, go get the data from probably Postgres, I guess. What is the data fetcher? Snowflake, great. And then you transform it, feature stores. So that could take, that's going to be sequential because I'm not calling parallel. So it's going to be like actually a DAG. So think A happens, then B, and then C. When that's done, then the loop continues. And as soon as we have new features, then this becomes true. And then you can kick off the training, right? So the training starts. And then as soon as you have a checkpoint, so the loop continues, as soon as there's a checkpoint, you can actually deploy. And now notice that all of this continues in its own kind of pattern, right? So the model's still training. Next time there's a checkpoint, the deployment happens again, right? And so it's all continuous training, continuous deployment, all the data stuff's continuous as well. So it's very, very easy to encode really, really complex workflows here. And as you're seeing, this is only like 10 lines of Python. The complexity is really pushed into each of these components, but you only have to pay the price to that complexity once when you build it the first time, and then you can use it across all the other projects. So just explain continuous training, continuous deployment. So we also have, I mentioned here that we have these components. Well, these are provided by the open source and you can build your own. So if you actually go to lightning.ai right now, you could actually go to the, and I'll walk you through it. You can actually go to the app gallery and component gallery, and here are some components that we already have, right? So you want to add serving to your workflow, great, it's there, and you have like 7 different strategies such as canary, recreate, ramp, and so on, right? You want to do an HPO, okay, cool, add an HPO component, and now you're going to be able to like run sweeps. You're going to take arbitrary frameworks, like you don't have to specify any of these. You just say, hey, here's a Python script. You can tell it, hey, yes, it happens to be TensorFlow or whatever, and it'll just like spin up the machines. And if you use, if those models are optimized for distributed training, then they'll just automatically work, right? Here, Jupyter Notebook, like if you want to have cloud notebooks on your apps and you're like, hey, I need to spin up and shut down notebooks for analysis, great, add the component and you can just start your own notebooks, right? So you don't need like specialized tooling for any of this stuff. You want messaging, Slack Messenger. So there's like all the observability. Hey, my training's finished, my deployment happened, this thing failed or whatever. Cool, add all of these if you want. And now you get notifications on email or Slack or whatever you want. And if you use Teams, for example, we don't have it here. Well, you implement it. It's like probably like a day of work to do that. And now you have Teams integration, right? We also have integrations with like the cloud providers, and basically like every ML company out there that's doing like MLOps or anything can have components here as well, right? So if they want to like, if you want to use another platform to do the training, you can do that, right? And you can plug into it, you'll send the model there, that does what it's going to do. And then you come back to the workflow on the Lightning platform, and then you continue to like stitch together the other things. I guess we're going to walk through this together. So since we're on our laptops right now, I just want to show you guys so that you're all up to speed and can do this on your own after this. So go to lightning.ai right now, and I'll give you guys a few seconds to get there. And once you're there, you'll feel free to scroll around for a second. The first part is going to talk to you about like what is Lightning, right? And so you can see that you can build models, which can be distributed, super scalable, research workflows, production pipelines, and so on. The question is always, where can I run this? So if you scroll down a little bit more, you're going to find that you can obviously run it yourself on your laptop. You can run it on any clusters you want. You can put it on any platform you're already using today. And then you can also run in the Lightning Cloud, which I'll show you how to do. You can use your own AWS account. You can use it on a private VPC, multi-cloud, on-prem, all that stuff. And what workflows can you build with this? Well, it's really up to you. Like it's like you're limited by your own creativity. So we put some example workflows, right? So first note that you can actually even publish full-blown products here, which I'll show you one of them. You can do workflows with cloud notebooks. You can do continual learning. You can compose stacks. You can do continuous deployment, data labeling, ETL pipelines, research demos. You can share your work. You can use synthetic data. You can generate synthetic data, right? You can do sweeps. It's really anything you want. You just have to build a component or find them on the open source. So if you're Lightning.ai right now, go ahead in the top left, there's an apps gallery, and I'm just going to show you how to like navigate this thing yourself. So in the apps gallery, if you click that, that's going to take you to here, right? So well, again, we only launched about a month and a half ago for this thing. So there are only so many apps built, but there's a ton already being built. But this one, for example, like what can workflows be, right? So let's play with this one, which is this workflow that lets you search within video. So if you click into this, you're going to see this page, right? So on this page, you have two options. You have this launch button, and then you have the clone and run. You can also see where the code lives, so it can live on GitHub or somewhere else, right? And to install this app, you can say Lightning install, you get the app and so on, but you don't have to do it on your local machine, right? So if you click on launch, you're going to see like a page that comes up, right? So I'm going to actually show you that with you guys. So I'm here and I click on launch and you're going to see this app come up, right? So notice this thing, like it is a workflow, literally. It's like an actual production workflow. There's pre-trained models, there's streaming, there's all this stuff. But it looks user-friendly, right? So which is wild. It's actually an app that people can use. Now, it's not meant to be used as an app. It's just meant to show you the end result. So like, let's say I work at like a big news company, right? Like, I don't know, pick CNN, NBC, something like that. And I decide to give our users the ability to search at the videos. Well, it's going to take you like 6 months to a year to like figure out how to do that on your own, right? You can come here, you can browse. You're like, oh, actually, this looks kind of close to what I want. So you basically click launch, and right now you can see the results before spending 6 months into this process, right? So I'm going to use this to search. I just have this video queued up, and this is a few minutes long. And obviously, if you want to search much longer videos, you got to like upgrade the machines and all that. But it's all in your account, right? So if I press this, this is actually going to index the video. So that ran it through OpenAI's Clip, which is open source, and then it extracted features. And now I can search this thing, right? So I can say, I don't know. Does anyone want to suggest something? I guess I can't see you guys. Yeah, let's see. Um, yeah, anyone want to suggest something to search on this video? Just type it, I guess, and submit it. I don't know if this works. Yeah, I don't know if that's going to work. Why not? Let's try it. Let's see if the model somehow understands names. um, yeah. So this is running distributed inference here. Yeah, okay, so I guess that worked. And actually, it even found the word, which is pretty wild. So I've never actually tried searching for a name, so that's cool. Yeah, so you see this, so you're like, wow, okay, you like have pretty high confidence now that you can build this thing in-house. Like, the problem with GitHub and everything else today is that you like find the code and like 3 weeks later, maybe it's not even running, right? So here, all I have to do is, if I'm at my company, I have my own cluster, right? So I go ahead, I put my, right now we have to ask you, we have to allow you to do it because it's private beta. But once it's out of beta, you basically do this, you add your own cluster, you don't run on Lightning Cloud, you select the other thing, and then you just hit clone and run, right? So I'm going to do that right now. So this now just takes that whole app and runs it on your cluster, right? So it's obviously using Kubernetes and a bunch of stuff under the hood, but you don't have to deal with the complexity there, right? So this will spit up machines. You'll see the logs, like all the artifacts and stuff are here. It's got environment variables. It tells you the hardware. It tells you the cost measured to the second. So you can know exactly what you're running. So I'm running this on the Lightning Cloud, which is like a public cloud. And it's backed by AWS. And to do that, all I had to do was buy credits, right? And I just buy some credits and then I continue running this stuff. So I guess this will take a few seconds to spin up. But the point is like within a few seconds, I was able to find the thing I wanted. I was able to test it immediately, run it on my own infrastructure within a few minutes. And now all I have to do is download the code. And because it's modular, I'll be able to actually like understand what's happening, right? So I can like basically take this code and let me see if I can find the VS Code is hidden. Let's see. So now it's a Lightning app, right? So everything's modular. Like if you don't want to download from YouTube, sounds good. Go change this component and make it stream from wherever you're keeping your data, from live cameras, whatever it is, right? If you don't want to use OpenAI, that's fine too. Go change this model with some whatever your favorite models are, your internal model, and so on, right? So it's super, super modular. So within a few days, I can probably modify this, maybe even a few hours. And then when I'm ready to go, all I have to do is basically run it here, right? So I say lightning run app.py. That will start the app locally. I won't do that right now. So you see it on your laptop or you see it on a machine that you SSH into. And if you're like, cool, let me run this on the cloud, I just say -- cloud and it off it goes into whatever cluster you specified, right? And so there you go. And let's see this guy. Cool. So it's only been a few seconds and this app is already running, right? So it's here. And then what you see here is the hardware, the type of machine that's being used. You see all the logs that are coming in, all the build logs, etc. You can filter them. Remember, these apps can be multi-machine, multi-cloud. So you can actually filter them by the machine type as well and where they're running, and so on. And then if this thing generates any kind of artifacts, you'll be able to see them here as well. So that's like the power of the Lightning Gallery, right? It's the fact that I can jumpstart something in a few seconds, which is really cool. So this is you can obviously use this to jumpstart internal ML projects at your company or your lab, and this doesn't have to be just for production. This can be for research. Like if you work at like a pharma company, all you do is R&D. There are Lightning apps that help you do exactly that, right? Really like model development, iteration, and so on. So if you feel motivated and you're like, actually, I just built a really sick product and I like actually want to productionize it and put it out there for people to consume, like Apple, right? Where you can launch apps on Apple, like Uber and so on. You can actually do that. So this is an app that we're launching next week, and it was built in partnership with NVIDIA, where basically it allows you to do synthetic data generation. So what you do is you drag and drop a few 3D assets into this. And then, so if you work at a warehouse, for example, and you want to train a model, you can actually drag and drop that into the UI. And this is a React application that's running. And then you're going to be able to say, how you want to sample this image and so on. You're going to compose a scene like this. And then you're going to say, yes, generate synthetic data for it. And it just starts generating synthetic data, right? This will spin up a bunch of containers with like 810Gs and so on, and just do what it needs to do. That data gets generated. And then as soon as you're done, you say, cool, train models. And then here, we're just going to use all the like open source models that are out there for computer vision. And we just treat them all as a sweep and just launch like thousands of them at once. And then you're going to see them all train. And then you're going to be able to take the outputs of those models and compare them against your particular thing. So notice here, there's not like TensorBoard, any of this. This app happened to be fully customized, right? So you don't have to be locked into any one particular tool. So if you want any kind of workflows and any kind of production systems, you can build your own adventure. You don't have to be stuck to like what other people are forcing you to use, right? And then this can be monetized, right? So NVIDIA will actually use it to make money on this particular product. So you can launch full-blown ML products as Lightning apps as well. So if you look into the code, notice if you're using PyTorch Lightning before, you basically were using the trainer and the Lightning module and the data module, right? So that's what was previously known as Lightning, as PyTorch Lightning. Now we've introduced 3 new abstractions, right? We've introduced app, flow, and work. And this is kind of like what lets you build apps, right? So the whole framework together is Lightning. And then the cloud compute part is really what's going to be like specifically doing the cloud operations, right? So that was one app I showed you. This is another app. This one lets you build research demos, basically. So I can I can put a blog post, paper. I can see the archive paper here. I can put a poster, right? So I can make a digital poster. I have a notebook with the stuff on here so I can play with it. I have the logs. In this case, I use weights and biases, so I can actually see the logs here. And then I actually have a demo built in so I can actually play with this thing, right? So this is research. So you can actually take these research demos, add an inference API to it, and then suddenly you actually have a kind of starting point for the production system. And then you can add drift monitoring, whatever else you want, and suddenly you build from research like very, very quickly. So we work with a lot of research on these things. This is the sweeps app. So this one actually lets you do hyperparameter sweeps. So this one, you basically just specify what script you want. And then in this case, we happen to be using Optuna, I think, or one of the open source things. And you're actually using the strategies from there, right? So you can use any of your favorite open source tools and their distributed training strategies to do the sweeps. So, and then, you use their UIs and so on the app. I have to say all of these apps literally were built in like 1 or 2 days, right? So you can actually build really, really complex stuff pretty quickly with like one person. So if we look at analyze the hyperparameter sweep app specifically, notice again, it's like 5 lines of code. So you have the imports at the top. Here we're using Optuna, we're using the distributions. And then we have this, it's now called sweep, but it's a component that we built, right? Which you can build your own if you don't like ours, that basically takes in a script path to whatever it is, right? Number of trials you want to do, the arguments to that, what type of machines you want to use for that. So if you're using PyTorch Lightning, you can say cloud compute 32 V100s and 100 trials, and I'm going to spin up 100 models, each on 32 V100s, right? And then what distribution and so on. And then this is a very, very simple app. All I'm doing is just starting this, right? So it just runs once and off it goes. And then the UI gives you what you saw in the UI as well, right? So what is under the hood? How does this work from the API perspective, right? You basically have 3 new abstractions: app, flow, and work, right? So I just showed you, if you want to run locally or in the cloud, you can just do this, and then the clusters will be automatically managed by what you selected. Let's learn how it works by example, right? So first, any meaningful work needs to be in something called a lightning work, right? So this is like if the thing takes more than like a second, it needs to be in a work. Otherwise, you can put it into a flow. So in the work, you're going to basically have this like score and params, right? So it's just the state of the system. And then all you're going to say is while true, while this is happening, you're going to like, this happens to be reinforcement learning. So I'm going to like explore, I'm going to run a model that explores, and then I'm going to get a score, right? So it's just like continuous reinforcement learning. So that's the work that I'm doing. I'm spinning up a little robot, and then it's going to do something, and I get a score back. Now the orchestration of the broader application is through this flow, right? So what do you say? You say, hey, I need some variables, right equals true, some parameters, and then this is my robot. And the way I start, I say, okay, cool. When the system is ready, so you spin up the system, the cloud machines have to come up and so on. You do like your safety checks. When that's ready, I'm going to actually run. When I hit that line specifically, that's when the machines will get spun up, right? So autoscales as well. And then as soon as I have a score that's more than 1,000, I'm going to store it. So I can run like thousands of these. And now I'm doing like reinforcement learning where I'm taking each rollout into its own cluster machine, right? So very straightforward. And then I have my flow and my app that I start. So I mentioned the event loop, which is really what powers a lot of this under the hood. So you have the app, you have a state, and that state changes every single time. So this event loop happens in like milliseconds, right? So if you're familiar with like React for building web apps, this is like React for distributed cloud apps. So how does this work? It's all kind of like a tree, right? So you have this flow that's composed of other flows, and these are the components that you're bringing in. And then you can nest this infinitely, right? So anytime there's an update to any of these things, they flow back up to a state, and then it gets pushed down to everything else, just like React. So what that means is that the system is fully fault tolerant. So if you want to like debug the system on the cloud, and you're like, oh yeah, like debugging distributed systems today is really complex, especially like distributed cloud MLOps apps. Well, here I can just pause the system, and I can say, wait, that variable went from 1 to 2, and the whole thing crashed. And you can actually see that, and you can rewind the state and actually reset the thing to a specific time frame, right? So it's amazing because it's all state driven. Now, some flows can orchestrate works, right? So the works have to be leaf nodes. So that means that like maybe this work is doing a deployment in SageMaker, and this one's doing like an HPO sweep or something like that, right? So these will get coordinated, and actually all the flows will live on one machine specifically. So you can even make it like serverless, and then the works themselves are going to live on other machines, right? So you can actually split this up. So then the state becomes distributed, right? So React is like a state that goes on that one particular web app. Well, in Lightning, the state is a distributed state that goes across machines and clouds, right? So anytime I assigned a variable or moved a file, to you, it was like self.var equals 1, or self.var equals like work1, dot value. And you're like, okay, I get the value from work1. But that actually was machine communication and even cross cloud communication that you didn't have to code up, right? So we just did it on the hood for you. So you saw that you can connect UIs, right? All you have to do is configure layout. You specify what UIs you want to put together. Any arbitrary UI, any React, Angular, Vue, like Gradio, Streamlit, whatever you want, right? You can build your own. There's built-in scheduling. There's no like special scheduling. It's just straight up, just like you can use the Chrome syntax, or you can just use like the human language, just like schedule every hour, daily, or something like that, right? So very straightforward. DAGs are like probably the easiest thing you can do on here, which is just like sequential processing. It's just call line after line after line, and you're good to go. You can schedule these very easily. I think the most powerful thing here is that you can compose DAGs, right? So you can take your favorite DAGs from whatever frameworks you're using and put them together using a Lightning app. So you don't have to actually like even get rid of those, right? And we have distributed storage, right? So like I said, if work A is training a model that's generating artifacts, but you need those artifacts to deploy in this other cloud, well, just by assigning the variables, we're moving all those files for you, lazy and so on, right? So it's a lot of complexity that gets abstracted out. And then if you want to like optimize it yourself, you can literally call put and list and so on, get delete on your own to make a super optimal version of this. So yeah, I mean, here's just, you create the drive, you say list the drive, you just use regular Python, you write files, you put, you list, get, delete, and so on. And like the whole point is that you don't have to learn any framework, right? All you have to do is you just know Python, that's it. So if you use PyTorch Lightning, you know this already, like you don't have to learn anything new. You already know PyTorch, just have to learn how to organize. Here, you don't have to learn anything new either. You just learn how to put these things together. And then the storage is distributed. So I showed you artifacts. Well, this artifact here could be in machine 1, this one could be in machine 2, and to you, it's just a single file system, right? I won't get into this. This is all file management stuff. And then we have the ability to have commands, right? So if you start up a Lightning app and like, I don't know, let's just say you launch that app to spin up notebooks, that's all it does. You just start a notebook, shut it down. Well, you can actually send the commands via the CLI, right? So it kind of like becomes an API that you can actually use. And so you can say, hey, start a sweep or shut it down or whatever. So it allows you to have CLI commands for any app you want. So you can build arbitrary services with this, right? So this one is just I mean, it's a lot of code to show, but like an example where all we did is we had this one command called sweep, and you can actually say now you can say lightning sweep, say the app ID of the app you're running, and you say here's the model that I want to sweep and the learning rate and so on, and you just hit enter and it just submits it all to that app, right? So the apps become services as well. And if you're not familiar with PyTorch Lightning, well, all of this can work really, really seamlessly with Lightning modules, right? So that's the other abstraction. So everything I've covered so far has been workflows, production pipelines, service workflows. But if you want to scale up specifically model training and model deployment, where you want distributed inference, you want all of this, then the Lightning module can do that, right? And in Lightning workflows can work with TensorFlow and everything else as well. But the Lightning module specifically works with PyTorch, right? So again, very simple. You say, hey, here are the models that I want to use. They can be pre-trained from your favorite hubs or whatever. And then here you just say how they're going to work, right? And then you log, and that's going to use TensorBoard or weights and biases or Comet or whatever you want. Validation step usually is the same as training step, but people might have different operations for those. And then the optimizers you want to use. So again, it's a recipe, right? So it looks exactly like the workflow stuff, where all you're seeing is like everything you need in a single class and no more. You don't see anything here about GPUs, distributed, multi-cloud, whatever. We handle it all, right? So how do you do it? You initialize your Lightning module. You also can create a data module or just use regular PyTorch data loaders. And this is cool. This is where the distributed part comes in. So if you guys have heard like deep speed and FSDP and blah, 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 these things that come out all the time, well, they're like a string here. All you have to do is say deep speed, press enter, and we just do it, right? So we will spin up the machines, we'll put all the models everywhere and do the thing, right? You can say devices, 200 accelerator, I can run on GPUs, TPUs, IPUs, HPUs. And we partner with all the hardware vendors. So when they release a new accelerator, Lightning is probably the first place where a lot of these things are available for you to like actually drop in, right? So, so if you want to try like IPUs or something else, just come in here, drop it in. And then you have to run those yourself today. But once we support those on the cloud, you'll be able to just say run on the cloud, and then we'll take care of it for you. So there's a lot of benefits, like I mentioned. Interoperability, Meta has a great article. They standardize all of it on Lightning. Why? Because it allows like the over thousands of engineers that work in machine learning across the board to use all the same components and all the same code as well, right? So we're like built for meta scale, right? Which is like kind of they're the only ones at that scale. So it works for basically everyone else. Ease of scale, like I said, you could go between all you do is change deep speed plugin, and suddenly you're training 45 billion parameters, much more than that if you want, right? Reliability, go look at our GitHub right now. It's open source. So everything that you're seeing right now is open source. The only thing that's not open source is like running on the Lightning AI, like all that stuff. that stuff is closed source, right? But like you can run stuff on your own, on your own clouds and so on. But if you go on the open source, you're going to see that we have tests across everything: CPUs, TPUs, different clouds, Azure, GCP, AWS, GPU, HPUs, IPUs. Like this is probably one of the most well-tested frameworks in the world, where you know that it's going to work on every single Linux version, OS X, Windows, and so on. So and there's a ton of built-in features specifically for the model side. You can export to Onyx, TorchScript, you have progress tracking, profilers, different strategies, like everything you want. It's fully configured, all the experiment managers you want, callbacks as well, which let you plug in different functionality to the training part of it. And then all these UIs obviously can be tied together through Lightning apps, all the distributed training ways of doing things. And there's just like literally like 40 more that I'm not covering. So documentation, pretty robust. So we have videos, we have classes, we have a lot of guides. Basically, if you want to get started, what I would say is go to Lightning AI. So you're already here. And then basically go to docs and you click on Lightning Framework and you're going to be able to get started here. I would encourage you guys to basically go through the app building skills here, basic skills, and just follow this guide. This basically gives you all the stuff that we're doing one step at a time. So you learn how to do one thing at a time. And then by the time you finish like level 7, you kind of generally know how to do a lot of the stuff. Yes, so I believe that's it. Please definitely go to Lightning on the GitHub and let's see. So go to Lightning, and obviously this means a lot for us in the community. So if you like what we're doing for you and helping out, like definitely give us a star and share with your friends as well. So that's all I have. Love to open it up to questions now.